Everybody, welcome to the stand-up for 31st of May, 2022 for Open Research Institute. And this is where we talk about what we've done over the past week, what we have planned for the next week, what we need in terms of resources, and whether or not there's any roadblocks. So the big effort here is to get a over-the-air demonstration in August for DEF CON. And anything else in the FPGA side that we can support that we need to do. But the big effort is to get the transponder working. Plenty to talk about. So I will hand it off first to James to tell us what's been going on at Remote Lab South.
Hello, everyone. I'm James, Kilo Juliet 7, Kilo Delta Echo, over at Remote Lab South. So far, we haven't had too much, no major weather events that have required us to take the equipment offline. So we've been maintaining a lot of our equipment here. We've had recent news from you, Michelle, about new equipment that might be coming over to this lab here, especially as there's a lot more effort going into cleaning up the barn, which is going to become the primary area where a lot of this lab area will be set up. And so a lot of exciting stuff going on there, but nothing immediately relevant still.
Okay. Yeah, looking forward to that. We'll continue to work on making it a special place. So Remote Lab South will have almost all the same equipment from that Remote Lab West has for DSP FPGA, but we're looking at also putting a bacteriophage or wet lab there as well. So lots of outreach will have to happen and support from iPath here in San Diego and possibly from UAMS in Arkansas. So we're looking towards that in the future. Yeah, thank you. Let me know if there's anything over the next week that you need. I think I owe you still some details, and we don't have a date for when we're moving lab equipment yet, but it needs to be sooner rather than later. Cool. Okay. Who's next? Go ahead, Anshul.
Yeah, hi. So not much progress from the last update. Just I've been trying to get the test running, but still not successful. So I'm waiting for you to come to that step, and maybe we can do something together. If needed, once we both are at the same stage, I can fly to US for a week, and then we can debug together and set it up. So just let me know. So yeah, aim is to get this ear-to-ear demo working.
Okay. Yeah, I'm going to be increasing the amount of time that I spend on it by quite a lot, which is exciting. So I'm able to some other stuff is ramped down, and hello, and and yeah, so all in, put my back in. So generally, like I like letting I like working from behind the scenes and letting people shine and everything. But I think that pressing a little harder and doing a lot more hands-on work might help over the summer. So I'm all in, and we have an additional resource. So Ken Easton has joined our team as a ASIC and FPGA designer from Qualcomm, and finally has enough time to spend on the project. So I think that we're in pretty good shape for the summer. And I'm still looking at other people. There's a resume that I have that was handed to me for someone that wanted an internship. And so I need to talk to her to make sure, like, is it a paid internship that's expected or not? So I will be doing that conversation very soon.
Yeah, I think now it makes sense. Now we have all the code in. It just need to get the product working. Last week I tried to reach Everest, but he was also busy, so I couldn't get my meeting time with him. So you have experience in this domain. I can code FPGA, but this is the first time I'm doing this communication thing. So yeah, that's where maybe we both can sit and make it work. We need to get it done now.
Yes.
It's high time. Yeah.
It is. It's time. So it's a good time to put our backs into it.
Yeah.
Yeah.
Just want to see that in action. Otherwise, it's just a code.
Yes. No, I agree. Couldn't agree more. So yeah, there'll be I'll have lots of dumb questions because my, I'll have to come up to speed on modern Vivado, for instance. But there's other things that I know how to do, and it's actually, I'm very confident that we can pull this off. So very much looking forward to August and then beyond. So that's That's what I think.
Yeah. And yeah, I will try to sort that out tomorrow, this compilation thing.
Yeah, the make failed for me on the code from you, which makes sense, and it followed pretty much the same path as Everest's Pluto code. We do have the bitstream from that. We're not sure how to test it yet, so I asked him, like, what was your test setup and what should we expect to see, and how can we prove that it's working on the Pluto, the same IP in the Pluto.
Yes.
So, but I'm very excited because the Pluto in the lab has the bitstream on it, and now it's just a question of constructing the right test setup. So that should happen and get a video and some demo documentation very, very shortly.
Okay. So how you got the bitstream to Pluto? I mean, you have bitstream, so you loaded the new kernel and everything, and bitstream along with it. That's how it worked.
Yeah, well, in running the make, the way that Everest said, it produced a bitstream, and then all I did was load up the bitstream directly on the Pluto using Vivado.
Ah, okay. So you don't have the PS component running?
Yeah,
no,
he did not. So there wasn't any instruction with like, okay, now then do anything with the processor side, but the bitstream's on it. So what I'm hoping to do is to be able to just, okay, so if I force feed it samples, and make it transmit, then I should see the evidence of the encoder working, I think.
Okay.
Unless it absolutely requires it to be configured, told what to do through the connections, for metadata. So that's what we've got today.
Yeah.
And then maybe by next week, it'll be really clear. So if there's anything that needs to be done on the processor side, I don't have any instructions for that, and nothing's been done as far as I know.
Yeah, the way I implemented is I loaded the Linux. I used Peta Linux config to include the bitstream along with the Linux, and then I loaded it so that if I have to do a DMA, because ultimately the packets will go from the processor side, DMA through the bitstream to the RTL, and then it should forward the packet over the air. So that was the path I follow. So yeah, we just have to mix and match, and let's see what one works.
Yes. Yeah, I'm excited.
We will try for the simpler solution in the phase one, and then we will go for the complicated one.
Yeah, really all we need is already in there. So the ability to change the mod code, and then externally from that, the ability to look at signal to noise ratio and make a decision on what mod code and where to be in the curve. That's looking further ahead. That's where we need to go.
And frankly speaking, Michelle, I had a discussion with someone from a satellite company, and there are so many parameters which actual customers demand, which we can implement in this module once we have this up and running.
Yes.
So yeah, it's a first step. Yeah.
Yes, very exciting. I'm confident, but it's going to be a lot of work. So, but we knew that.
Surely.
Thank you so much. All right, Paul, you have the floor.
Okay, well, a couple of things. Starting with the remote lab. Except for borrowing some equipment for local testing, there hasn't been a whole lot going on, but there is a new version of the Unraid software that we rely on for running virtual machines. I've installed it on Remote Lab South, and then I reinstalled it because there was another minor rev. Maybe we'll wait a while for that to stabilize out before installing it on Remote Lab West. It doesn't have any features that we absolutely have to have, so we can hang on to that for a while. And we'll need to find some period of time where it can be installed without disrupting work. The other thing I'm working on is not exactly FPGAs and not Remote Lab exactly either, but it's oriented toward testing of implementation in the future, hopefully not too distant future, of testing the multi-channel uplink receiver by generating a simulated multi-channel uplink signal. You may have seen that I published a few videos with demonstrations of little baby steps toward doing that, starting with a single M17 signal and then multiple M17 signals done a couple of different ways. And finally, one with 9 M17 signals, which shows the way to doing a massively parallel simulation of lots of M17 channels. And that's, for now, that's probably as far as we're going to take the M17 channel, because what we really want to do is something a little bit higher voice quality for multi-voice uplinks with accommodation for broader band non-voice channels as well. So taking a step back and trying to figure out what that looks like, or some kind of prototype that at least approximates what it will look like, so we can start mocking up some multi-channel test of that sort, which will make a fun demo too. So that'll be essential, I think, to qualifying the spacecraft software with the multi-channel receiver on it. So that's what's going on here. Plus, I've been working a little bit with Michelle on trying to get the Pluto and so forth tested out and working. So that's my report. No blockers at the moment, except time and intelligence and knowing what we're doing.
Thank you. Yeah, the work with the Pluto, what we started out doing with that was to make sure that we knew how to restore it back to a configuration that could be used by anybody for any purpose. And we think we know how to do that. We know how to restore the firmware, and we know how to restore the stock bit stream that goes in the FPGA, and everything seemed to work okay. And then we also learned a little bit more about how to operate hardware with Simulink from MATLAB. And it's extremely similar to GNU Radio in that you drag and drop blocks and you connect up the blocks with wires, and it's a flow graph. It has its own quirks and learning curve. So that's also been going on. And yeah, that's the focus. There's the uplink simulator is exciting and necessary. And then having both parts, the transmitter and then the receiver part, I don't think we've done a whole lot of work on at all, but we should turn our attention to that as soon as we get the transmitter in any state where it can deliver the things that we send it. So as soon as we get the processor side, direct memory access and baseband frames doing anything reasonably reliably, then that time is the point where we then go, okay, now we need to be able to multiplex what we were receiving. So that'll be pretty exciting, and we'll have there'll be all sorts of problems and mismatches and bits leaping off the edge of the table and disappearing, and and we also will find out some surprising things, because we do want to tackle a control loop for adaptive coding and modulation. So there's a lot in there, and there's also a lot in just general quality of service. So handling digital data versus voice, and all of the fun things that we've talked about with voice. So anyway, things are going pretty well, and my hope is that with additional resources and by really increasing the amount of time that some of us are spending on it, that we will start to see all of this code, the disparate chunks, come together and actually work over the air. So again, the goal looks like mid-August, which is going to come up really, really soon. And every week should have good progress towards that. All right, any other comments or questions before we close? Cool. Okay, see you on Slack or an email. Need anything, please let me know.